hope everyone had an awesome weekend. Today is the last lesson that you're going to have to deal with this video, but thank you so much for your participation this week and for working so hard. And know that you guys have just been amazing and complete rock stars. Please also keep in mind that tomorrow you guys are going to have a review day before your test, your first big test of the year, Unit 1 test on Wednesday. So this is the last day of notes that you're going to have for this test. And the notes today are 1.13, Scaling Graphs. Today is September 12th, 2016. Please make sure you have this titled at the top of your paper and you are ready to go. Before we get started, we're going to write a quick definition of what it means to scale a graph. So write this right below your header. So a scale, it actually is less of a definition, more like why we do it. So it helps to make your graph easier to use and read. So if you remember from your do now, you probably talked a little bit about like this wasn't being very consistent and things that you could have done to fix it and make it more clear. But now what I want you to do is go ahead and turn to the second page of your do now packet, so the very back of your do now, and I want you to take a minute to look at these two bar graphs. These bar graphs show exactly the same information. Although it doesn't look the same, this graph is a little misleading. Determine why the graphs look so different, even though the data is exactly the same. So take just a minute and do some quick annotations. What are you seeing and why do these graphs look so different, even though the data is exactly the same? What you should have noticed here is that this graph on the right, on the left, your starting data is like 82, and then you have 83, and then it ends at 84. That's being graphed on this bar graph. So we only have two numbers in between here. Whereas here, my starting number is somewhere in the 80s, and my last number is probably somewhere in the 80s. I can't tell exactly what it is. But there's no real clear space about like what is happening in between these two pictures. And that has a lot to do with the scale. So this one has a small scale, which makes it easy to read exactly what's happening in between the two colors, this like teal color and this green. And this one has a large scale, which makes it a little bit more difficult to read and see what's happening here. And also really makes this one look drastically different, where here you wouldn't think that the amount of freezing temperatures between 2007 and 2008 was a big deal. They're pretty close together. We probably wouldn't even talk about this graph if it was in front of us, but this first graph definitely looks like there's something major going on until you look at that scale. So what we're going to do is we're going to practice making scales. So you are the head, What I want you to do is to do exactly what you did yesterday with your notes. So take the last page of your packet, rip it off, put a piece of tape at the very top of this page and tape it right underneath your definition of scale that you wrote in the notebook. Then you're going to fold the bottom of the page up so it fits neatly in your notebook, but you can open it back up to write your notes and to study. So example 1, you are the head of the admissions at Yale University, and for your very first assignment, you are to create an appropriately scaled graph to represent the number of applicants over a set period of time. So below is the data that you will use. We're going to look first at our data for the year. So my year range is from 1999 to 2004. When you're finding the range, you're subtracting your largest number and your smallest number. So 2004 minus 1999 is equal to 5. So this means I need 5 different places that I can label numbers on my graph. If I look at my scale here, I'm going to put the year at the bottom. I end up with 5 boxes times 4, so that's 20 different spots. So to figure out how often I can actually write a number, I'm going to do the 20, the number of spots I have, divided by 5, which is equal to 4. So that means that I can, for every 4 boxes, write a new number, and it'll fit all of my numbers on here. The next thing we're going to do is that same thing, but for the applicants. So I'm just going to put APP. Now this range is going to be a little bit different. I'm going to subtract 31 and 8. And this is going to give me 23. So if I include this bottom line, I need to have at least 23 additional places that I can write a number to get all of the applications to fit. So I'm going to do this exactly the same way. I've got 23 places that I need to write, and I have 20 boxes that I can fill up. So if I do that math, 23 divided by 20, that's going to give me 1.15. So that means every box I can write a new number. Actually, technically, that means every box, or 1.5 boxes, I can write a new number. So I'm actually going to run out of space. So this number is just a little bit bigger than the number of boxes I need. So I'm going to end up counting by a number that's just a little bit bigger than 1, but not too much. So I'm going to start by counting by 2's to get to all those numbers. So my first year here is 1999. I'm going to label that. Now we said every 4 boxes I can write a new number, so I'm going to do 1, 2, 3, 4 boxes. This is going to be 2000. I'm going to turn this sideways to fit it. And then I'm going to count 4 more boxes. 1, 2, 3, 4. This is 2001. 1, 2, 3, 4. This is 2002. That was 3 boxes. 1, 2, 3, 4 is 2002. 4 more boxes is 2003. And I'm left at 2004. Now, as I said here, if I count by 1s, everything's not going to fit in the 20 boxes. It's close. So I'm going to count by 2s and start at 8. So that means this box is 8. This one would be 10, 12, 14. This one's 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, and now we keep going. Because I'm writing with this like huge stylus on my iPad, this is probably a little bit more difficult to see than it is on your paper. Make sure that you're just keeping your scale small enough that you can fit all your numbers, and you're doing it in a neat way so that you can go back and read it. So now all I'm going to do is just graph these numbers. At 1999, I had 8. So I'm going to start my point right there at that like origin 1999 8 place. My next one happens at 2012. So I'm going to draw my point at 2012. and 12. My next point happens at 2001 and 17, so that's right above the 16 line, but not quite at the 18 line, so kind of in the middle there. My next one happens at 2002, and it's at 21, so again, it's going to be in between two boxes. My next one's 2003 and 23, so again, right above the 22, but below the 24. And my final one is going to happen at 2004 and 31. It's going to be up here. And then all I'm going to do is just connect my points with a line as neatly as I can. And you have just scaled your first graph. If we go ahead to example 2, we're going to do the same thing. We're going to start with the year. If we go ahead to example 2, we're going to do the same thing. We're going to start with the year. Here you've got a brand new job with the government. You're in charge of graphing the information as obtained at a census. A census is just a document that they send out about every 10 years to figure out the population of the United States. So we're talking about the years from 1910 all the way back to 1810. So if we find that year range, we do 1910 minus 1810, and you get 100. Again, we're dealing with the same kind of boxes as we did before, so we're going to figure out how many boxes we can use to write numbers. So 20 divided by 100 is equal to 0.2. So that means every fourth of a box we can write a number, or we should probably just go ahead and count by 4s or 5s to get all of these numbers in. The next thing we're going to do is we are going to do the same thing with the population. Actually, let's go ahead and graph this. I said this is very close to 1/4. If it was 0.25, we would have 1/4. I don't like counting by 4s, and these are all nice round numbers, so I'm going to just bump it up to 5s to make it a little bit easier on myself. So that means every box on my axis, I'm going to count up by 5. So this starting year is 1810. The next box would be 1815. To save some space, I'm just going to do 1820 on my paper, but know that every box is really 5. So 2 boxes is 1830. 2 more boxes is 1840. 2 more is 1860. 70. 80. 90. This is the year 1900, 1910, 1920. And I'm going to label this here. So now let's figure out the population in millions. So again, we're going to start with the range. So 92.2 and 7.2. So the population is 92.2 minus 7.2. When we subtract this, we end up with 85. So if I do the same thing like I did before, I had 20 boxes divided by 85. I get 0.23. Remember, this is one of those cases where we said this is really close to the fraction 1/4. So I can go up by 4s every single time, or to make it easier, I'm just going to go up by 5. So they're just nice, neat, round numbers. And I'm going to start at 5. So as long as you're in the same neighborhood, it doesn't matter if everybody's scale is identical. You just need to have a scale that's easy to count by, easy to read, and spread your data throughout the graph. So I'm going to start this side at 5. The same way I did before. I know that each box is 5, but to save some room here since my marker's so big, I'm going to skip 2 boxes, so 10. Actually, that should be a 15 because I'm going up by 5. So 2 boxes is going to be 15. This is going to be 25. 2 more is 35. 45. 55. 65. 75. 85. 95. And my very end is 105. So now I just need to plot my information, and I'm going to do this in this orange color. So in 1810, we had a population of 7.2. So that's somewhere around this 5, but not quite 10. In 1830, we had a population of 12.8, so that's just below the 15. In 1850, so that's between the 1840 and the 1860 box, I had a population of 23.1, so I'm going to go up just below the 25 box and draw my point. In 1870, I had 38.5, so just above my 35. In 1890, I had the point 50.2. I'm going to go up here just below the 50. This should actually be right on that intersection because I skipped by 5s. And then 1910 goes all the way up to like 92. So just below this this end part. It means we had a big population jump there. And then I'm just going to connect my points to show how it shifted throughout the years. You can see a little bit of a curve here. So again, the major thing here is just making sure that you have enough data that it's being spread evenly throughout the graph like we did here, that you're not scrunching everything up in a picture. Sometimes we make a scale that's too small and our graph is going to end up looking like this. And then you have like nothing up here and it looks really crazy. It's hard to read. You can see here in the last 2 graphs that we've done, our data is spread out pretty evenly. We can see a clear picture of what's happening. Yours don't have to be identical to mine as long as it's very close and it's similar. So go ahead and practice with this by yourself. Complete the rest of the problems in your packet. Be sure to complete the exit ticket as well. I will be back tomorrow. I'm so excited to see you guys. I hope you have an awesome day. Bye!